Imagine a visitor from another star system, hurtling through our solar system before vanishing forever. Meet 3I Atlas, only the third confirmed interstellar object ever recorded, and perhaps the strangest yet. Its chemistry, trajectory, and sheer age are rewriting what we know about cosmic wanderers. Stick around, this is going to get fascinating. First detected on July 1, 2025 by the Atlas survey in Chile, 3I Atlas swooped into our cosmic neighborhood at a staggering speed over 130,000 miles per hour on a highly hyperbolic trajectory with an eccentricity greater than 6. That means it's not linked to the sun at all, but is simply passing through from the depths of another star system. It's the fastest and most eccentric interstellar object we've ever seen. Estimating the nucleus size of this comet is tricky since it's cloaked in its glowing coma. Hubble suggests the actual nucleus is under 1 kilometer, but the surrounding gas and dust cloud extends up to 20 kilometers. That makes it potentially the largest interstellar visitor yet. Even more intriguing, 3I Atlas likely originated from the thick disk of the Milky Way, home to ancient stars. That means it could be between 7 and 14 billion years old. Far older than our 4.6 billion-year-old solar system. Telescope teams around the world sprang into action. Gemini North captured its compact coma. Hubble recorded detailed snapshots. Then came the juggernaut, NASA's James Webb Space Telescope, using its near-infrared spectrograph on August 6, 2025, peered deep into its chemical makeup. And the results? Stunning. 3I Atlas's coma is dominated by carbon dioxide, with a CO2 to water ratio around 8:1, one of the highest ever documented in any comet. That's 6 sigma above what we'd expect for similar comets. Minor traces of water, carbon monoxide, carbonyl sulfide, water ice, and dust also show up. What could explain this odd mix? There are 2 leading theories. First, it may have formed near the CO2 ice line in its home system, far enough from its star so CO2 could freeze, but not water. Alternatively, the comet might be buried under a crust that blocks heat from reaching the water ice, favoring outgassing of CO2 instead. Meanwhile, the Very Large Telescope spectroscopy revealed more surprises, growing signals of nickel Ni emission and emerging cyanide CN, indicating that as 3I Atlas warms, it sheds metal atoms and molecules increasingly. The release patterns suggest these aren't just typical sublimation, but possibly complex extraction processes from dust grains. Adding another layer, the Swift Observatory detected hydroxyl emission in ultraviolet, the first direct sign of water, albeit from icy grains lofted into the coma, not sublimating directly from the nucleus. Activity levels are high, with at least 20% of its surface actively releasing gas. Don't worry, 3I Atlas poses absolutely no threat to Earth, staying safely beyond 1.8 astronomical units even at its closest approach. Scientists are treating it as an extraordinary scientific opportunity to sample material from other corners and eras of the galaxy. 3I Atlas has defied expectations at every turn, old fast, CO2-rich, and incredibly rare. It's not just a comet, it's a messenger from the ancient past. And as next-generation observatories like Vera Rubin and more join the hunt, who knows how many more secrets the cosmos will share. Hit subscribe and join us as we follow the next visitor from beyond.